Alright, we continue our study of exponential and logarithmic functions. In this video, we will focus on solving exponential and logarithmic equations, such as these. And for the first time, we will be allowed to use our trusty TI-30 XS multiview. Alright, number 11. There are two ways that we can solve this equation. At a glance, I'm noticing that 49 can be written as 7 squared. So one technique would be to go 7 to the 2x minus 20 power is equal to 7 squared, like bases. If the bases are the same, then the exponents must be the same. So 2x minus 20 must equal 2. And then we would add 20 to both sides. So that will give us 2x is equal to 22. And then if we divide both sides by 2, we get x equals 11. Okay, so that's one way to do it. Now, here's the other way. Logs equal exponents. So whenever my variable is in the exponent, logarithms are my best friend. If I rewrote this in log form, it would look like this. Log base 7, there's my base. The rest of it will change sides of the equation. So I would have 49 over here, and I would have 2x minus 20 over there. Now, a log is the exponent that changes this number into that number. So 7 squared is 49, so this will become 2. So I have 2 equals 2x minus 20. Alright? If I needed to do this in a calculator for some crazy reason, which you shouldn't, I could put in the calculator as log 49 over log 7. That's the change of base formula. So I could go log 49 over, log 49 over log 7. Okay, but you should definitely be able to look at this and know that it is 2. The rest of this is the same as the other way I just did it. Alright, I will add 20 to both sides and get 22 is equal to 2x divide by 2. Either way, we get x is equal to 11. Alright, number 12. We have two bases being multiplied together. Alright? It's like when I have n to the third power times n to the fifth power. What's that going to be? Is it going to be n to the 15th power? No, it's going to be n to the 8th power. Alright, so you recognize if we have like bases here, we add the exponents. Now, what if I had 5 to the third power times 5 to the fifth power? Okay, the big mistake is some kids want to go 25 to the something. No. N. Okay, this is not going to change to a 25. It's going to stay a 5, just like n stayed an n. This is going to be 5 to the 8th power. Okay, and the reason why 5 to the third power is 5 times 5 times 5. 5 to the fifth power is 5 times 5 times 5 times 5 times 5. If you put all that together, I have 8 things. Alright? I have 8 fives. Alright? 5 to the 8th power. These do not morph and suddenly become 25s. So no, you don't multiply the bases together and make 25. Okay, so getting back to the actual problem. So if you see I have the same base, what I need to do is add the exponents. Alright, so I'm adding 2x plus 1 and 5x minus 2. So it's like I have 5 to the, and then I'm doing 2x plus 1 plus x minus 2. And of course you really will do this in your head. I'm just showing it for instructional purposes. 2x and x make 3x. Positive 1 and negative 2 make negative 1. Okay, so you really could have done that in your head. Alright, let's liberate the exponent by rewriting this in log form. In log form, it would look like this. Log base 5. And then these two parts are going to change sides of the equation. So the 2 is going to come over here, and my 3x minus 1 is going to come over here. Alright, so I still need to get x by itself. So let us add 1 to both sides. Okay, please don't add the 2 and the 1 and make 3. You can't do that. You just have to leave it on the end. So this will be log base 5 of 2 plus 1 is equal to 3x. Don't make this into a decimal right now because you're going to end up rounding. If you do make it into a decimal, at least keep 4 decimal places until the end of the problem. But I would leave it alone. Now, to get x by itself, we will divide both sides by 3. Okay, so that is going to give us the final answer. Alright, now in your calculator, however, there's no way to type log base 2 directly in our calculator. So what we have to do is use the change of base formula on this part right here and rewrite this as log 2 over log 5. Okay, so I'm just rewriting. This circle has become this circle. So I've still got the plus 1 and the over 3 part. Okay, so I'm going to type this in my calculator. So let's see. Let's start with the big fraction that has a denominator of 3. So go to your calculator, go into fraction mode, go in the denominator, there's your 3. So that's this. Now we'll go into the numerator and create this. So up in the numerator, I see I have another fraction coming, so I can go into fraction mode again, and this is going to be the log 2 over log 5. So I go log 2 over log 5. Okay, and then I have the plus 1, so plus 1. So there it is, 0.49. Got to round up. Did they say how many decimals? Nearest hundredth. Okay, that's what I thought. So x equals 0.49. Alright, if you did not like what I did with the whole nested fraction thing, what you could do instead is do it in steps. You could do the log 2 divided by log 5 part first. Okay, some students prefer to do it this way. Log 2 divided by log 5. Alright, and you get an answer. Now don't round this. You know, next you're going to add 1, so you can just go plus 1 and hit enter. Alright, now you got this. Now you know you have to divide by 3 now, so you can just go divided by 3. Alright? Why am I getting a different answer? Oh, because I'm not getting a different answer. I just looked at this and somehow wrote 0.49. Okay, let's just pretend that didn't happen. So this is 0.48. Got to round up, yes, but rounds up to 8. So don't know what that was all about. But good save, I guess. Yay. All right. Either way, we get the same answer, 0.48. All right, moving on. Number 13. Oh, well, this is relatively easy. We've got the same log on both sides. So logic dictates that the argument here must be the same. So the 3 minus 2x must equal the x minus 9. Now, before I go any further, remember, you cannot take the log of a negative number. So when we have a log equation, whatever we get for the answer, we need to plug it back in and make sure we're not getting any negative numbers in here. So anyway, let's when I see x's on both sides of the equation, first thing I do is get those together. So I will do that by adding 2x to both sides. Alright, so that's going to give me 3 equals 3x minus 9. So next I would add 9 to both sides. So that's going to give me 12 is equal to 3x. And then I will divide both sides by 3. So x is equal to 4. Now let's just make sure this is not extraneous. In other words, let's make sure it doesn't give us any negative numbers. And right away I see a problem. If I take this 4 and substitute it back in, alright, for example, say if I put 4 right here. Alright, well that's 4 minus 9. That's going to make this the log base 3 of negative 5. And you cannot take the log of a negative number. Alright, so similarly over here, if I put the 4 here, that's negative 8. Minus 8. 3 minus 8. Again, that's a negative 5. This has a value of negative 5. No good. So that means this is extraneous, and since that was our only solution, that means in reality we have no solution. Alright, number 14. Okay, we don't have logs on both sides, so look, what we need to do now is condense. So let's see, where's my little cheat sheet? I don't need it, it's for you. We're going to do the quotient property in reverse. So if we have a log minus a log, that'd be the same thing as having a single log and a quotient. So when I have a log minus a log, I can rewrite that as a single log. Okay, log base 3. And then I'll just do the log base 3 of this over this. Okay, so that'll be x squared plus 8 over 4. Alright, so that's all I've done so far is condense this subtraction into a quotient. Now, I don't have logs on both sides, okay, like I did before. Like on the last problem, I had log base 3, log base 3. I could just set these two parts equal to each other. Here I just have log on one side. So what I need to do is rewrite this in exponent form. So in exponent form, you start with the base 3 here. So this would be 3 to the, and everything else is going to change sides. So this and this. Okay, these are going to change sides. So this 3 is going to come over here and become the power. This is going to go to the other side. So I'll have x squared plus 8 over 4. So now I need to solve this thing. Of course, 3 to the third power is 27. So I've got 27 is equal to x squared plus 8 over 4. I will move that 4 by multiplying by 4 on both sides, like this. Okay, so 4 times 27, which I, of course, could do in my head. But there you go, 108. So I have 108 is equal to x squared plus 8. Subtracting 8 from both sides. Then we have 100 is equal to x squared. So of course then we will take the square root of both sides. Okay, and be careful when you take the square root of both sides of an equation, the answer can be positive or negative. And we have to consider them both as possible solutions. So if I put positive 10 here, then I have 10 squared is 100, so I have 108. So that's fine because it's positive. Now, if I put negative 10 in here, negative 10 squared still is positive, 100. So I still get 108, it's still fine. So both the positive and negative 10 work, so I must include them both as solutions. So x is plus or minus 10. Alright, so if you only put positive 10, you're only getting half credit. Alright, number 15. Have to solve this guy. So let's add 7 to both sides. So that's going to give us e to the 7x minus 5 power is equal to 15. Now let's rewrite this in log form. Normally that would mean log base e of 15 equals 7x minus 5. Because once you go to log form, these two parts are going to change sides of the equation. But we never write log base e, silly. Log base e is natural log, so we just write natural log 15 equals 7x minus 5. So let's continue. Do a couple algebra steps now. Let's add 5 to both sides. Please don't add these together and make 20. Okay, you can't do that. So this is going to be natural log 15 plus 5 is equal to 7x. So then we could divide both sides by 7. Okay, and that's going to really give us the answer right here. Alright, natural log, let's put this off to the side. Natural log 15 plus 5 over 7. Alright, so natural log 15, close your parentheses, plus 5 over, what was it, 7? So there you go, 1.10. Alright, and that's going to be a convenient place to end this video. On the next video, we're going to do some word problems. Alright, we're going to solve some real world problems involving logarithmic functions and exponential functions. So I'll see you on the next video for that.